So we've transitioned now from the hypothetical, the theoretical, to the practical, and I'm joined by Rob Thatcher, VP of what?
Security.
At CTCI.
There you go.
So if there's one person that knows how all this stuff works, it's this guy.
We'll see.
Exactly, we will see. Now, what I really want to do is get into a deeper conversation about what all these, as Leo Des calls them, blue blinky lights that are happening in here, right? Because when you walk into your IDF closet or your server room, you probably see a can that looks like this, and maybe you've opened it one time and you go, what the heck is that? Or, and I see this a lot too, is folks that don't understand what really goes into an access control system might say, I don't understand why this is so expensive. It's just a reader and a door lock, isn't it?
Right. It is that.
It is. It is. And that's what people see when they come to a door. And if the systems integrator is doing the right sort of job, it's super seamless. I present my card or my phone to the reader, it goes beep, and I walk through the door. But to make that thing beep, it's a lot of stuff going on in here. So what I thought would be cool is, Rob, take us through what the heck we're looking at here.
Okay, well, this is, let's close it up a little bit. Not an HID product, but a life safety power enclosure that's meant for, specifically for Mercury hardware, an HID product.
Yes, and by the way, Life Safety Power is an ASSA ABLOY brand.
Oh, there you go.
And ASSA ABLOY is the parent company of HID who makes the readers and the panels.
Part of the family.
It's all in the family.
So, I didn't realize that. I learned something today.
So, I'm here to teach.
Awesome. So, Life Safety Power traditionally made power supplies.
Right.
Thusly the name.
Yes.
But it became apparent to everybody, man, wouldn't it be great if we could put all of this in one enclosure, because in smaller implementations and even in larger ones, this makes for a neater wall field.
Yes.
You've been in hundreds of IDFs, I'm sure. These are on the wall, and sometimes you've got one reader controller after one reader controller all over the wall in legacy systems.
Your whole wall ends up becoming a sea of red and cables.
Right. So this seeks to minimize that, which we like. We want to keep it as tight as we can. We don't want a lot of real estate. We want to be, as you said, it should be as seamless and invisible to everybody as it can be.
Right.
So this is why we use these or companion products like it.
Right.
This is our production Genetec system, which I think you know a little bit about.
Yeah, a little bit.
So this runs our doors in our office.
I see.
We are using this for local testing, and the reason we are, being that you are the mobile evangelist, we have set up our mobile credentials on here so that we can test them as part of this.
Absolutely. And by the way, something that we're going to do later, this reader here, which we see all the time, this is Prox Only. This does not accept a mobile credential. If I took my phone and presented it here, nothing's going to happen. We're going to upgrade this to a Signo reader that can do a mobile credential utilizing the same wire. But we'll talk about that in a second.
When we get there.
Yes.
But here, so again, another HID product, Mercury 1501 for non-Linnell friends. This is a Mercury 1501 running the show here. This is simply a controller. All this is doing for us in this context is processing card holder data. It knows that these boards are here. It tells these boards that the readers exist. It tells these boards what card numbers are allowed access to what portals, to what doors.
So so you might refer to this as an intelligent controller or an IC board. And literally, this is the brains of the operation. Without this, these, what we call like downstream boards, these wouldn't really know what to do. It's getting all of its information from here. This, over the network connection, is what's communicating with Genetec. Is that correct?
That's right.
So then I only see a couple of wires coming out of this board. Where are these wires going and what are they doing?
I'm glad you asked. So these are, well, there's power for one. The second set of wires is RS-485 communication. So that's down to the downstream boards, as you said, and that's allowing us to get information from Genetec to here and then over those wires to these boards.
And now these boards are controlling the doors.
Correct.
Okay. Why do you have multiple panels here. I guess it's more than just this reader.
That's
I'm assuming.
right. Yeah. This is very small. There's only 4 readers on this, including that
Got it.
currently, and this is where we're connected. So each of these MR52 boards controls 2 doors.
Right.
And that's it. That's the.
So now there's other boards in here, and this is again one of the things that folks don't understand. There are. When you're messing with access control, unlike video, right? I can take a 2 megapixel camera or a 5 megapixel camera or a 4K camera, put it up in a room. So long as it's recording, I'm good. Right? In access control, this is actually a life safety issue, right? People's lives depend on whether or not these doors open when they're supposed to open and close when they're supposed to close. And that's not just access control. That's like in the case of a fire, I need free egress. I need a free path. Every door needs to unlock and get me out of the building, right? And that's what these ostensibly are doing. Can you talk us through like what these devices are actually doing?
Right. So at the basic level, this is life safety power supplies.
Yes.
These are power supplies. We're getting power from here. We're distributing it here with these boards. We are monitoring it with this board, which is a network link board, which brings us outside of this CAN and gives us some insight into how the power supply is performing.
Right.
Also gives us insight into how many cycles we've had on a relay, which might tell us the life of a lock.
Oh, okay.
In advance of its failing. So we can.
So you might get a call for service to say, hey, my door lock is not locking anymore. You can log in and say, oh, well, it's been through 10,000 duty cycles. I'm going to come down to the site with a new lock versus it's only been through 100 duty cycles, maybe something else is up.
Or we can say, we've reached a threshold, have this board send us an email and say, contact your customer, you have an imminent failure of a lock. So
that's cool.
Yeah.
That's cool.
So there's some intelligence there, which is great. And then the next piece of this that you were mentioning is life safety. We don't have to worry about it here because we have all electromechanical locks and all of our doors are easily exited.
Right.
So there's no way that you could be trapped.
Right. But if you had doors with like a mag lock, for example.
100%. Those would be required to unlock in a fire. There's a fire input here. So you would get a closure, a relay that you would pull off of the fire system. If the fire alarm were to activate, the relay would change state. This would change state and unlock all of the doors that we want unlocked in a fire. Right. In some cases, like IDFs, if you have a vault, things of that nature, you may not want them to unlock, and it may not be required that they unlock. If it's an exit path, it's got to unlock. If it's an internal door that's holding sensitive documents, sensitive items, probably not necessary. Check with your local AHJ.
Yes.
Don't take my word for it.
Yes.
But we can set those parameters on the board, in the programming, all of that good stuff, and in the case of a fire, an activation here means an unlock everywhere.
Right, there's a cascading effect. Now,
correct.
In that scenario, there would be a fire panel mounted here or somewhere close.
Or somewhere.
There's going to be a wire that's going to go from there to here. What's making the decisions, like once I get that contact closure here, what's making the decisions to unlock those doors?
This power supply does that for you. So this is going to say, hey, if I have something connected here and the settings are just so, dependent on the behavior of the relay, this is what we're gonna do.
Right.
And when I deviate from that is when I change.
Gotcha. Now, you mentioned programming.
Yes.
Where are you programming that?
This particular board would be programmed through the Netlink on a web browser.
Got it. If this were 6 years ago and the Netlink didn't exist, how would you program it?
You would have to, well, there's no real programming. Then it's dip switch settings. So then you're moving a bunch of dip switches around, which has its benefit. But certainly, there's an enormous benefit to not having to do that and having visibility externally as to how it is programmed.
Yeah, because if it's dip switches only, you have to trust that the technician knows what they're doing at the dip switch level and didn't accidentally leave one up and one down, and then the whole thing doesn't work. And really, you're only ever going to find that out if
when there's a problem, we'll know.
If the stuff hits the fan. Right. Now, these are sealed lead acid batteries. You've got 2 of them in here, 12 volts, 7 amps each. This is your battery backup for this whole thing. So if your power failed in the building, these are going to kick in. There's no time delay.
Immediate.
Immediate. How long will these last?
Well, borrowing from your nomenclature, it
depends.
right?
Right.
It depends on how much is on here. With a nominal load, a small load, you could go hours,
Right.
Not days, hours.
Right.
But it will give you the opportunity to make arrangements for power or make decisions about what you're doing with the building.
Right. At that point, you're probably evacuating the building or something
Sure.
to that effect.
And also, if you're in, we don't, but in an environment where you have a generator, if you do not have batteries, the time that it takes for the generator to come back online, you will be off.
Right.
So if the power goes off, your generator will wait, and then it will come online. If you don't have batteries, or you don't have batteries that are well maintained and are working, which is very important, and that's why minimally we have a technician write the date that it was installed. And then when we do preventative maintenance, we check the batteries and make sure that they're charging, make sure that they're holding 13 volts, 12 volts,
Can you get that information from the
can.
NetLink?
We can get it from the NetLink.
That's pretty powerful.
So yeah, absolutely. So, but in a very analog way, if we needed to just put a meter on it, we could. But it's important to make sure your batteries are actually working.
Yeah.
This will give you the gap between the power loss and your generator coming on.
Right. So sometimes, especially when I used to work at Genetec, I would get the question all the time, like, why can't Genetec or my access control software, my head end, take the place of these boards? Why do I need intelligent controllers and these downstream boards? And I'm hoping that the audience is starting to gain some insight into this if they were thinking that, because these boards are actually doing a lot more than just blinking. Right?
Sure,
There's a lot of stuff going on here. Can you take us through, like, what happens if I pulled this plug right now and the intelligent controller loses its connection to Genetec? What would happen here?
If it's done properly and everything's working properly, nothing that you would notice as an end user.
Right.
When this is unplugged, the system would tell us, hopefully, if all things are operating the way they should, would tell us that there's been a communication failure. A user presenting their card would see no difference because all of the decisions are being made here.
Right.
The entire database of cardholders and the schedules and the access rules are all stored here. So this little guy is doing all of that processing and making sure it gets done. It's also saving all of the records as that happens if it's offline. So when this gets plugged back in or your network comes back or whatever it is, the server comes back on, all of that data will download and you will have it locally or on your server.
This whole system acts almost as a fail-safe in that event, right? Because it's far more likely that the network's going to go down or your server's going to go down. And at that point, you need the local decisions to continue to be made. Otherwise, people aren't getting access to your building. So in that eventuality, that plug is pulled or the network dies or the server dies, I present my card to this reader, it's still going to work, and then it'll get me that information back to the head end once the head end comes back online. The only thing that you are not able to do at that point is make any changes to your schedules or do any sort of remote control of this because you're down. But everything else ostensibly is still functioning in its last known state.
Right, absolutely. And so you made a really good point there, and that's something that people forget. If this is down and you don't know, if you terminate somebody, if you have to take someone's card away, if you gave someone a new card, it's not making it here. That information doesn't exist as far as this set of electronics is concerned.
Right.
So it's very important to keep an eye on it, and it's important that as integrators we set these things up so that notifications are available and persistent. So that this isn't forgotten about and we can take action.
So now, obviously, you've got life safety going on here. You've got physical safety and security happening here because we want to keep the bad guys out and keep the good folks in. But what about the security of this stuff, right? And what I mean by that is like the cybersecurity. This is a network connection. We've got wires going to different places. How is all of this secured?
Again, it depends. It depends. If it's likely that in older implementations, particularly readers that are Prox Only running over Wiegand because it's an aged...
like this.
Yes, like that one. Because it's an aged technology, there wasn't a lot of thought behind this. It's literally a wire that is 0 and a wire that is 1. And if you can make those things do that without somehow alerting the panel through a tamper on a reader or something like that, then you can get in.
Right.
As far as data security is concerned, we have hardening practices that we do that are recommended by Mercury, by HID, and by the manufacturer of the system, in this case Genetec, where we do the best we can to make sure that people aren't getting in. On the reader wiring side of things, if you are using Wiegand, again, it's loose. It's very easy to defeat. OSDP, which is the new generation of wiring that's coming back to these panels, will allow us a lot more security. We will have 485 that is RS-485 that is encrypted, and yeah, could you? You could get in there, but it will take
Way
a lot more
difficult.
effort.
Yes.
Yeah, it will take much more effort than this would take.
Yeah.
This is a $15 device on Amazon.
Right.
OSDP is going to take you a lot more work, and it will most likely be abandoned for an easier target.
Yeah, 100% right. Like, there's a lot of buzz in the industry right now, especially around this device called the Flipper Zero.
Right.
And
yeah.
Flipper has unbelievable power to defeat systems like this, especially older technology going over Wiegand, or if it's just a simple Prox reader. Yeah, if I could flip those ones and zeros easily with a Flipper device, yeah, I can defeat this system. But by moving to a technology that's not from the 1980s,
Sure.
right, and
Yeah.
moving to a wiring standard that's also not from the 1980s. Fun fact, if you Google Wiegand, the only pictures you can find of Mr. Wiegand, John Wiegand, the inventor of the standard, are black and white photos. So that should tell you something.
A
Little bit. So if we're moving towards an OSDP style of wiring that allows for that encryption layer, and we're not using Prox, so 125 kilohertz Prox, and we're using 13.56 megahertz smart card, high frequency technology, or mobile credentials, it's far more difficult for an attacker. And this is, I'm going to go on a rant.
Go ahead.
For a second.
As you do.
Because you know what grinds my gears? You know what grinds my gears? When folks on the internet that have platforms talk about physical security, and they talk about how insecure certain technologies are, and it's a little bit of like a fear-mongering kind of thing. Yes, 125 kilohertz Prox, you should never deploy that. When you're deploying a new system, it should always be wired OSDP, and to Rob's point, you should be using the best practices for encryption standards that all the manufacturers allow. Make sure your firmware is upgraded, blah, blah, blah. Like these are obvious things, because all we're trying to do in the physical security world is deter, delay, and deny intruders. Deter, detect, delay, and deny. Those are the 4 Ds. That it says nothing about prevention or stopping somebody from doing something. If someone is well-intentioned enough and has enough time and enough resources and the gumption to get into your facility, they're going to do it.
Right.
The practice of a physical security professional is to make it so difficult for them to pick on you that they go pick on someone else, okay? So do we make it easy for an intruder to attack our facility if we're using 125 kilohertz Prox reader on the outside of our building? Yeah,
Yep.
Absolutely. It's the same reason why you really don't want to put like an RJ45 jack on the outside of your building that's connected directly to your network. You would never do that. You should never do this. If we want to make it even more difficult, we're going to go from an open communications protocol in Wiegand, and we're going to go to a secure channel, OSDP v2, from the reader to the panel. We're going to make the panel communicate to the IC over an encrypted layer, and the IC is going to communicate over an encrypted layer to the access control head end. So we've made it extraordinarily difficult for somebody to pull something off. Again, is it possible?
It's
that
possible.
that they may somehow subvert all of this with enough time and resources, but what they would need to do in order to defeat a system like that is they'd have so much time at the reader, they'd have to take the reader off the wall, they'd have to get into the wiring, they'd have to connect a whole bunch of doodads and a computer. If your physical security practice doesn't pick up on this, right, if you don't have a camera or a security guard or something like that, and you've given somebody unfettered access to sit there for 2 or 3 hours to try to figure out and break through your encryption standard, well, that's a failure at a whole different level.
Right. We have bigger problems than
You've
the
got
reader.
different problems at that point.
Right.
So, thank you for coming to my TED Talk. Rant complete. So,
Tune in the next 5 minutes for the next one.
that's right. It's coming. So, what I thought would be really cool, these folks at CTCI have set up this environment to allow us to do several things here. Thing number one, we're going to replace this old Prox reader with a modern Signo reader. We're going to do that, thing number 2, using the existing weakened wire, but wire it up for OSDP, because this is one of the other common questions that we get is, can I use OSDP, or will it require me to completely rip out all the wire that I have now, which would make the project way more expensive, right? The answer to the question, spoiler alert, is no, we can reuse the existing OSDP wire. And then we're going to jump into Genetec and show you how easy it is to provision a mobile credential to this reader with really having done nothing else other than changing the reader out.
Right.
Sound like a plan?
Sounds like a plan.
All right, let's do it. All right, Rob, so as promised, we are now going to change out this old Thinline 2 reader, which could only read Prox, right?
That's right, yeah.
Only read Prox. And I've been making posts about this on social media. You walk around everywhere and you still see these, which means any facility that you see that has one of these is vulnerable. I'm not suggesting you should do anything untoward, but as a security professional, if you own or manage that building and you see this on the outside, it's time to change. And what should we change to? Well, in my opinion, because I work for this company, but in general, as a physical security professional, you want to upgrade to the most modern technology you possibly can. This is an HID Signo 40 reader. It happens to have a keypad. There are versions without a keypad. There are thinner versions as well, with and without keypad too. But the reason why you want to upgrade to this is it will still support Prox. And if you have these, you probably have lots of Prox cards out in the field. You turn Prox on this, and then you start to deploy a more secure credential, whether that's MyFair Desfire EV3, iClass, CIOS, or a mobile credential. This will accept all of them. And then once all your Prox cards are gone, you turn Prox off, and now you're secure. And when I present that Prox card to this, it won't even do anything. Right? It's completely turned off. So what I thought might be interesting is to take the audience through the process of actually upgrading a reader.
Sure, let's do it. I will warn you, I haven't done this in a while, but I have done a lot of these.
He's very modest.
This reader does not have an easy way of getting the cover off. So you kind of have to pry it, and it may or may not hit you in the face when I pull it off of here.
This is real world. As real world gets. I'll stand back.
You might need it.
There it goes.
Oh, I caught it. Look at that.
Good catch.
There we go.
That's it, huh? There was
that's
no
it.
screws.
That's the whole thing. And that's, listen, one of the reasons you want to replace it is so that Phil doesn't have to get plastic surgery if he's near any one of these.
Or your technicians.
Right. We're on a 1900 box with a single gang adapter on it. It's not a mud ring. This is just the adapter. None of these screws are tamper-proof.
Right.
They should be.
In the field, they really should be.
Right.
Although I have seen regular Phillips or flathead out in the field as well, which is obviously not best practice. I think one of the other cool things, and folks who were really listening would have heard it, I heard a click when you pulled this off. What was that?
It was coincidental.
Oh, okay.
This came off the wall. Someone read a card out there.
Okay. So there's no tamper
going
on here?
Not on these readers. No, sir.
Oh.
Yeah.
I didn't realize that.
The optical tamper, well, there was a legacy physical tamper that was on the, I don't know the model number, but it's the 4-inch by 4-inch version, the gray HID reader. These are 5395s, right? These are 5395s. I can't remember the model number of the other one, but it's the Prox Pro reader.
Right. That had a tamper.
Yeah, it has a physical tamper on the inside, and a better means of getting the cover off, but still prying and flicking.
The old pry and flick.
Yes, my favorite move.
But there's no tamper on this, right? So once you took this off, there was no alert to anyone that somebody is now tampering with your reader.
No.
Okay, well that's a problem.
And then the optical tamper came out on the R40, and then carried to the RP40. Yep. So you don't see much of that anymore. Ignore the go light over here. This is our door unlock signal.
Right.
We'll show there. Right in the face. That was great. I'm warning you.
Do you have to turn off the power here? to work on this reader?
Should you? Probably. Will your guys in the field? Probably not. I mean, that's the truth of it. But I will tell you, once we get into provisioning the reader, this is really not a one-person job. This is a two-person job because there are power cycles that are required during the provisioning cycle.
Right.
Which, by the way, HID, that's not optimal. You got to have two guys to replace a reader. Come on. There's a bunch of stuff that has to happen there.
Right.
So, which we'll go over.
Sure.
But yeah, a lot of times these are done live.
Okay.
Guys are doing these in the field just by isolating carefully the wires.
Gotcha.
And making sure that we're not touching power to anything that would cause a problem at the panel. But yes, best practice, friends. Unplug your reader. Lights out. All
Lights
good.
out.
So, and that is really, so what you might see is guys will do this and cut them with the B-connects on them.
Why would they do that?
So that they're not, you don't have copper touching anything.
I gotcha.
But still, it's not as though you
Tricks of the
couldn't
trade.
do that. Yeah, it's not as though it's impossible that something's going to get up inside the connector,
Right.
but still.
Really shouldn't do that. You really should pull the power.
But, the simple fact of the matter is that that's what people do.
Right.
A technician is very likely not going to power down your panel in order to do this,
Right.
or even pull the stuff off, just as a matter of time savings.
And now I will say, this is an older style HID reader, and there are tons and tons of these out and about. If you walk the streets of New York City, you'll see these literally everywhere, to the point where they're like sun bleached, and you barely recognize them anymore, but they still work.
Yeah.
These are workhorses.
Oh, they work great.
Yeah, and as are panels as well. Like, these things typically don't get touched for 10 or 15 years, like once
Right.
they go on the wall. But that does not mean that technology doesn't get better and that things don't become vulnerable in that time frame. These are ostensibly computers that can have their firmware upgraded.
Right.
This is a dumb device. This
it's
cannot be upgraded in any way, shape, or form. Outside of maybe some very minor firmware stuff, but you're not putting encryption on this anymore.
No, it is what it is. They do work great. That HID was so confident in how well they work that there was a lifetime warranty on these.
Right.
I believe that's still being honored.
Absolutely.
If this goes bad and you want another one, send it back.
Yep.
They'll give you a new one. And they do work great. But as you said, there are
limitations.
Yeah, there are
real
limitations.
real consequences to those limitations.
One of the nice things about the newer readers, so this started with the R series readers, is these are two-piece. So there's a back plate that goes on first. And then there's a set screw in the bottom of the back plate that holds the reader
unlike this, that you had to get all these wires up into here and then put this on and then put the plate on.
Right, and so there's no prying, there's no pulling, there's no guarding your face to see what happens next. It's very predictable. We know what's going to happen, and your face is safe with this reader type. Really live.
Yeah.
All right. So we're going to do our best not to over-tighten this guy. Also, please don't use a screw gun on this.
Why?
Please. Because you're very likely to over-tighten it, crack the plastic, and then wish you hadn't done that.
Right. And then
you're
you're calling
probably
HID for a replacement.
Right, you probably don't have a bunch of these on your truck, and if you over-tighten it, it's either going to pull straight through or break, and neither of which is what you want.
Right. Now, there's a lot of wires here, and I think this is something that, again, folks sort of take for granted, right? You see movies, and the movies are like, oh, just touch these two wires together, and it'll get the door to open.
Oh, the classic. What's the movie?
Yeah, exactly. Cut the red wire.
Matthew Broderick, the
Ferris?
No, War Games.
Oh, yeah.
Where he's locked up in a government facility and he pulls what is probably a barium ferrite reader off the wall and has alligator clips that he got from somewhere, and he's able to jump some stuff, and then he unlocks the door by replaying a code through a recorder. That's movie stuff.
Yes.
Movie stuff. Although Flipper does something kind of like that.
That's true.
Over the air.
And over with Wiegand, it is possible to replay a Prox, an unencrypted
Yes.
Prox read. So it's not all that far-fetched. But what a lot of folks don't realize is exactly how many wires are being interacted with here. And each wire has a specific task. It's not just power.
Right, so this is power, right? Your red wire is your 12 volts down to the reader. Back in the day, this might have been a 5-volt wire. And you better have observed whether it was a 5 or a 12-volt reader, by the way, because there was no auto-sensing.
Once the blue smoke comes out, it doesn't go back in.
You can't get the genie back in the bottle. That's the unfortunate reality of it. So power here, ground here. If weakened, these are your data wires. This is data 1 and data 0. If you think of data 0 like a ground, green and black, that's how I always remembered it. It was my little mnemonic. And then your LED wires are here. This controls the red LED, and this controls the green LED. And that's really kind of historic. Now it's kind of resting LED and on action, something that this will tell it to change state. But with Signo readers and OSDP, that is no longer the case. The behavior is determined inside the reader based on OSDP settings and what's being sent to the reader.
Right.
So now we have two-way communication with the reader, so we can make it do all kinds of things that we couldn't make an old antenna do, essentially.
Gotcha.
So
before you move forward with this step, so we took this reader off. This was obviously wired up for Wiegand.
Right.
We're going to wire up this HID reader for OSDP, but we're going to use the same wires. So what we said before, right, power, data, LED, how does that change in this world? Because we're reusing the same wire that we were using for Wiegand, now we're going to use it for OSDP. What changes here?
Right. The only thing, we're actually eliminating 2 wires. We're going to do red and black for power, and then white and green for data.
And that's it?
That's the whole thing.
Wow. Okay.
Yep.
So if you have more than 4 conductors, you're good.
You are good. Yeah, absolutely.
What is the technical limitation? Right, so let's say I do have some super old wiring. I have these 6 conductors. Because there are wiring standards for OSDP, right?
Right. Well, the previous wiring standard, let's start there. The Wiegand wiring standard was 500 feet on 18-gauge wire. Most installations are 22-gauge wire, and they're likely closer to depends on the links, but most people didn't. I've found very long runs on 22 that work just fine.
Right.
But standards are there to make sure that you don't completely egregiously do crazy things with it and expect
if it's 500 feet and you're 550, okay.
Right, you got some play. And if you're lucky with voltage drop and things like that, or you have a very tolerant reader like this one,
workhorse,
you can get away with going a little further. It should really be 250. I think was the published standard was 250 feet on 22 gauge wire.
Right.
OSDP, honestly, I think it may be longer than this, but I want to say it's 2,000 feet over. The standard wire now is 24 gauge for that, so it's an even thinner gauge wire, but with more of a twist in it and with lower capacitance.
Got it.
And that'll allow you 2,000 feet. And really, it's just a protocol change we're using rather than the very simple high and low of Wiegand. Now it's data communication over RS-485.
Gotcha. Okay, fair enough. So the likelihood that you're running into 24-gauge wire that's been run more than 2,000 feet on an everyday basis is probably pretty low.
I mean, let's hope that's not the case. I've certainly seen or been told, hey, there's Cat 5 to this reader. How's it working? It's solid Cat 5. It's a very long run. Again, when you have tolerant electronics or very good back-end electronics, you have a better shot at this stuff.
Right. But obviously, stay within the spec. But in practice, these types of things are possible.
Yeah.
So while Rob is messing with this, so this is the Signo 40, like I mentioned earlier, and the Signo 40 is available in a multitude of different flavors. One being keypad version, one being without a keypad version, and that's obviously if you want PIN codes. Don't use PIN codes. Please don't, because as soon as you give someone their PIN code, guess what they've done? They've given it to someone else. So you can use it in combination with other things, right? So something you have and something you know. So something you have could be your phone or your card, and something you know could be your PIN. So for multi-factor authentication, this is good. But you could do multi-factor authentication with a mobile credential and never have to use a PIN number ever again. So really, never deploy a PIN code as your sole source of access control restriction. So obviously available with and without the keypad, also available with and without this pigtail. So there's a terminal strip version. There are pros and cons for each. Some folks prefer the pigtail, some folks prefer the terminal strip. Are you a pigtail guy or a terminal strip guy?
I'm torn on this because I'm a standards guy, standardization for the group, and so also look, I'm an old dog, right? All of the readers we ever used, with the exception of the Prox Pro, were all pigtail for years. That's just what we got when I came up in the industry. It's not that they didn't exist, the terminal strips, so we just didn't use them. But we don't like using them on exterior readers. And the reason we don't is because they're not weatherproof.
Oh, okay.
You know, so we prefer to use B connectors, but the blue version of these with silicone inside on exterior readers. They're messy. It stinks when you have to take them apart and put them back together if you have to replace a reader, but
it's going to work.
It will work. You could also use the terminal strip with dielectric grease, I'm sure would do the trick.
So you would use terminal strip maybe inside and pigtail outside.
Yeah, if I were to do it, but because it's easier to buy 100 pigtail readers, I'd rather just do that.
Yeah, that makes sense.
Again, it's personal preference. If you like one, use that one. They do exactly the same thing from an operational perspective.
It's just what it looks like on the back.
Yeah.
Yep. All right, so we're at the point where we're going to start wiring this thing up. As you can see, these wires have not been exposed because we're not going to use them anymore because we're doing OSDP. So it's these two wires for communication, these two wires for power. That's it.
Right. And one of the other important things when you're, just a note that we try to observe here, is if you're installing a reader and you're not using the wire, cut the ends off and isolate each of these individually. Because if they touch, there's a beeper in here, there's a hold function, there's all those things. If they touch, you can lock the reader up. You won't know why. I've seen this happen before. We'll put that in there. These are all twisted together and then taped with miles of tape. Please don't. Please don't. Anyway.
So best practices, clip them.
Yeah, clip
isolate them.
If you don't use connectors on them, cut them at different lengths and tape them off or something like that. But we'll safe them off individually with connector, with B connectors here. So
we're only using the red, black, white, and green.
That's correct.
What the heck are all those other cables?
Well, there's the two LED wires, which we're not using. There is a hold wire. There is by the way, I rarely use these. There's a hold wire. There is there's an external beeper wire, so you can use that. Actually, with very common with Mercury installs, if you want the reader to beep on a held open or a forced open, you can hook up the beeper wire, which is yellow, I think, direct to the buzzer output on the reader terminal block, and that'll give you an audible indication that something off normal is happening at the door.
And that's buzzing at the reader or
the reader
the
beeper will beep.
Right.
And these aren't really all that loud unless they're only loud when they're next to your desk and you're trying to work. If it's in a hallway, no one's coming to your rescue. The door's open, good. I don't have to open it. That's what we typically see, unfortunately.
One of the common questions I get is, where do you learn this? Did you go to a trade school? Like, what was your path?
My path was, I was a computer guy in the late 90s, and a friend of mine was looking for someone who understood, quote, computer stuff, who had an integrator called Corporate Security Services in Edison, New Jersey. And, they had a bunch of access and alarm guys. They didn't have people who knew, networking. And they didn't have people that knew computers in general. They had maybe one person that was really, really good at it. And that's what I was brought on for, because most systems in the late 90s were directly connected via RS-485 in a chain down to a server that wasn't sitting on a network at all. And if it was a network that was cobbled together that was only existent in the security console, which tells you exactly the era that I started in, right? And no, there was no trade school. I was fortunate to be mentored by guys who had been in the business for a number of years, a couple guys that had owned their own businesses previously, and it was very tribal. You know, there was no apprenticeship program. There was no, you know, you couldn't go to school for it. And the truth is, you really can't go to school for it now.
I was going to say, there are very few programs in the U.S. that are specific to our industry, physical security.
I can tell you that there are trade schools that do things that prepare you for low voltage work. There are apprenticeships available through local unions that are helpful, that get you ready for low voltage work, but nothing that is system specific. A lot of it is just you got to learn as you go. You're going to learn from mentors and people in the field that you're shadowing. I had about 2 weeks, and then they threw me to the wolves, and I was luckily it was you know, hey, go to this. This is telling. Go to a bank branch and change the lens on this camera.
Wow.
You know, and a lot of it was, you know, it was a lot of travel.
Yes.
And it was not a lot of working because it was going between sites and doing, you know, kind of small things.
Right. Yeah, back then there were no net links to tell you if the power to port number 1 is working.
Right. We didn't have that sort of. So I'm not taping anything here again. This is our lab environment.
Yes. In the field, you would tape these off.
You might. I'd prefer you didn't. You know, a little bit of tape never hurt anybody, especially if you're isolating copper. But what happens is you wrap tape around these things. You have this knot of tape that someone now has to remove later.
Right.
And
who
in
knows
the
what they're
heat and the
pulling
cold
off.
and whatever, in the cold it'll get brittle. In the heat it will melt, and there'll be glue everywhere. It's a
mess.
It's unfortunate working environment when you get there. So if you can avoid it, please do. You know, the next guy will thank you for not having done that. He'll probably be a guy who says, I don't know why I didn't put any tape on this. But at least you wouldn't have had to deal with it. Okay, well, that's that. I'm just going to get the set screw, and we'll be right back.
And now, of course, the beauty part with this, with the Signo 40, obviously same lifetime warranty. So if for whatever reason the reader did experience some sort of an issue, now all you have to do is take out that set screw, remove this module, replace it with the new one, and you don't have to mess around with the back box.
Thing that makes it so that you don't have to throw the cover across the room.
And wear your goggles.
Yeah. There you go. That's that. It's in.
That's it. It is in.
So we are going
So
to
now we're
plug
going to plug it in. Hey.
It's
Beep.
alive.
It's alive. Now the purple indicates that it's booting up, right?
That's right, yeah. And in its default state, the way that it comes from the factory, it'll go to red when it's ready to go.
And where are we changing the LED colors?
In Reader Manager, in the phone
In
app.
the app.
Yeah.
So that's another big differentiator between the older technology and the newer technology is now technicians in the field can go out with an app and communicate directly with the reader.
That's right.
And now we're
ready.
ready. So now he's using Reader Manager on his phone.
Right.
He's going to scan for readers. Now there's 2 readers there.
So this is interesting, right? So we have a mobile configured. It's operating as a reader that accepts credentials that comes into our lab. We have tagged that reader, and it says that it's for the 152 is the number of the building we're in, lab. So that is that reader. And then HID reader shows up. Now, if you were in a very large implementation of readers, let's say there were 20 or 30 readers on a floor, you may see all of them.
Right.
But what you need to look for is the signal strength.
Right.
The lower the number, the closer the reader.
That's right.
Okay, so if we see the one that is at 43 dBm, that's the one that is right in front of us.
Yep.
And if I were to, just for illustrative purposes, I disconnect that and let's stop scan and restart it. Now I can only see
Right.
the 152
So
lab.
now we've isolated that is indeed the right one.
There is a firmware update. We're going to do the firmware update, but I will caution you that it takes longer than you think. So
Yes.
have a place to put your phone, and you may walk away because it's going to take some time, and you'd rather do that and walk away than try to play with your phone while you're doing it. So
Right.
Squirrel brain gets me every time.
All right, so we've completed the firmware upgrade. It took a good 3 or 4 minutes to do. All of that information was passed to the reader over Bluetooth. So now we're ready to install the mob key on here, right?
That's right. So we're going to close, theoretically, we're going to close this guy. And it's going to find the reader again, or inspect the reader again and give you all of its details.
Right.
And now it tells you there's the loaded and available releases match, which tells you that your firmware is at the highest available rev. We're going to apply template, right?
Yes.
Click on that guy. I just so happen to have a CTCI Worldwide HQ template already built. But for fun, let's create one just so that we can, this is for a keypad, so let's make sure that we have a separate one for that. So there are a number of different settings here. One of the things that Phil mentioned earlier, which we're not going to turn off at the moment, but we will later, is the ability to turn off or turn on particular types of communication.
Yeah.
This credential screen is where you would do that, and you'll see that HID and AWID proximity, very interesting for our overseas friends, EM proximity. Dorado is in here, but off by default, and Indala on by default. You can turn all of those off. So all of your low frequency protocols can be turned off.
Right.
And once you do that and apply the template, you will no longer be able to read those card types. Well, we'll leave it for now so that we can test it.
One other important thing to note there, too, is you could turn off BLE. And for a lot of discriminating customers that are concerned in their organization about having Bluetooth turned on and having a lot of Bluetooth transmitting and traffic in their facilities, like a big no-no for them, turn off BLE right there.
So keys. We have one key available. We'll click Add Keys.
That's our mob key.
Right. And this is the one that is assigned to CTCI.
Yep.
I just whacked my
microphone. That's
microphone.
Okay.
So go ahead and edit that out. So we've added the keys. It's now in the list. We say Add to the template. Done. We're not going to change any of these things at the moment. Phil, we might want to go through ranges and power levels of Bluetooth later, but it might be out of the scope of this video. And what we like to do here is audio and visual. Our idle LED color we're going to set to blue, which you can see was red. Adding that to the template because we want CTCI blue. And the closest thing to orange we have is amber. So we're going to select amber because our colors are blue and orange. We'll add that to the template.
So when somebody presents their credential and they're allowed in, it'll blink orange.
Right.
Got it.
And then there they are. And we're going to
save your template.
Save the template. It's going to ask for a title, and we'll call it. And that's it.
Done. So now, how do we push that to the reader?
So we're in the area where we would select it. We're going to go ahead and do that and hit apply. Now, we're being asked to power cycle the reader. So we're going to go up here and unplug it. And this is where being a one-man operation doing this becomes difficult.
Yes.
In a sterile environment like we have, this is nice and easy. But once power cycled, now it begins to write. And if you look at the reader, you'll see it's in that read-write mode where you see blue and purple going back and forth. And then it says, template applied successfully. And now it's reading my mobile credential.
Yeah, there you go. So we've gone through the process of upgrading that Thinline 2 reader to a Signo 40. It is configured. It is ready to go for a mobile credential. The proper mob key is on there. It is now wired OSDP to the reader, so we now know that the communication path is secure. And as Rob mentioned earlier, we can even turn off Prox when we're all done with this. So I thought what would be really cool is let's jump into Genetec, which is the access control head-end software that CTCI uses here to actually provision me a mobile credential. All right, Rob, it's my first day at the job at CTCI. I guess welcome or be afraid.
You mostly welcome.
Okay, perfect.
Mostly.
So
we considerable longer period of time than 2 weeks to be thrown to the wolves here.
Perfect. Perfect. Thank you. I appreciate that. Our Signo 40 readers on the wall. You've put the mobile credential, or you put the mobile key on there, the mob key, and now you're using Genetec Security Center to configure access control rules and privileges. I would like a mobile credential, sir.
All right, well, let's go ahead and I will record this screen. I'm going to get rid of this. And we're going to add you. So
tell me when you're going through that process.
I'm going through the process now.
So what we're showing on the screen now is the process that you would use in an access control head, and this one just happens to be Genetec. No smoke and mirrors here. What's happening is behind the scenes, there is an integration to what we call Origo portal. The Origo portal, think about that as like your box of cards on the internet. Genetec Security Center is plugged into Origo, and when Rob enters my new cardholder information, it is going to kick off a workflow that is going to send me an email with a 16-digit code, which I will put into the HID Mobile Access app. And if everything works according to plan, I present my phone to the reader and I'm off to the races. Versus what you'd have to do in a normal situation, or versus what you would have to do in a non-mobile situation, which is request a physical credential from someone, go to a card office, get your picture taken, wait for the thing to be printed out, or if you're like me and you work remotely, your organization is going to have to ship that card to you, which is an extra $5 to $10 in shipping costs to get your physical credential, which just adds to that additional cost that we talked about earlier. So let me know when you're ready, sir. So at this point, once he hits save there, I will have received an email with that credential. So I'm going to open up Outlook on my phone, and there's the email from HID Cloud Services. I open that up. I already have the HID Mobile Access app on my phone, so I don't have to download it, but you can see there's all sorts of instructions for folks that maybe don't have the app on their phone. That link with the invitation code is clickable. If I click that, it will automatically put that invitation code into the app. And now I simply hit Add Mobile ID. There's my card. And now you can see there's 2 readers there. And now all I have to do is present it to the reader. So now that my mobile pass has been provisioned, and again, I didn't have to go to a card office or anything like that. I literally just received an email and put the credential in there. I have my app, it's open, and I'm through the door. Or I could even, as I'm getting close to the door, hit that little button, and the door opens. And you may be saying to yourself, well, Phil, that's all fine and good, but do I have to have the app open in order for the credential to transmit? And the answer is no, absolutely not. So here you can see my phone is off. I present my phone to the reader, and I'm through the door. Very similar experience to that of a card. This is an app-based credential, which means the credential is living inside of an app. The read rate is a little bit slower than a card. A card is about 200 milliseconds. This is about 500 milliseconds. But so long as you train your users on the slight differences that they may experience, this is going to be way more convenient for them than them having to remember their card. And again, like we mentioned in the interview with Mike, there's so many other user benefits that come along once you transition that physical card to mobile.
Okay, what a tremendous summary on mobile credentials.
Everything you ever wanted to learn, and probably way, way, way more.
Yeah. Tons of information. We'll chop this up. We'll get it out in bite-sized pieces.
Yeah, absolutely. And maybe even some long-form versions for those of you who are looking for like security industry ASMR to fall asleep to. We got you covered.
If you have additional questions with regards to integration and installation on mobile credentials, please contact us below.
Yeah, absolutely. All of our contact information will be down below if you'd like to learn more about HID, Mercury, Signo, mobile credentials. I'm the HID mobile evangelist, Phil Coppola. All my contact information will be below. If you want to learn more about how all this stuff connects together and you need somebody to put it in for you and you're in the New York metro territory.
Or simply support it.
Yeah, or support it. CTCI is the company for you.
Thank you.
Thanks so much, and we'll see you on the next one.